Hi, welcome to an Introduction to Logic. I'm Mark Thorsby, and this course overviews the basics of categorical, propositional, and predicate logic. Okay, so today we're going to be taking a look at in categorical logic are Sorites. And Sorites are sort of very interesting. In fact, there's an infamous paradox called the paradox of the Sorites, or the Sorites paradox, that's related to this issue. We are going to be talking about that in our other video, our video series on the history of the development of logic, which is going to be coming out over the next couple of weeks here. But in logic, especially in categorical logic, Sorites have a very particular form. So let's review real fast. In our last section, we looked at enthymemes, of course. You all remember that. An enthymeme is essentially when you have a missing premise or conclusion. What we're going to see today that a Sorites is what you do when you have multiple missing premises and conclusions. And they're all mixed together, but they ultimately form one larger argument together. So let me see if I can give you an example here. Oops, let me just scroll down here. Give you the definition. So what is a Sorites? Well, strictly speaking, a Sorites is a chain of categorical syllogisms It's a chain of categorical syllogisms without intermediary conclusions, or without the intermediate conclusions. Now, it's sort of interesting, when we looked at enthymemes, what we found is that mainly we were talking about premises that are missing or conclusions that are missing. When we talk about Sorites and categorical logic, what we're going to discover is that each intermediate conclusion functions as an intermediate premise. So we're still talking about premises and conclusions. So let me see if I can give you a sort of quick example here. Let me scroll down here. Okay. So what we're going to see here is, imagine, for instance, you have one argument. We'll call this argument A1. And the argument 1 results in a certain sort of conclusion. Let's call this conclusion 1, right? So the argument here is, of course, two different premises that are formed together to create a conclusion, right? Now, so how does this work? Essentially, what happens is you have the conclusion of one argument becomes a premise in the next argument. So you take the intermediary conclusion, add it with the next premise that you do have, and then that's going to result in C2, because these two premises combined, this is essentially the second argument. This is the first argument, this is the second argument, where these are the premises, right? And then C2, of course, gets combined with P3, right? And this will form the second argument. And then finally, it will result in some sort of major conclusion. We'll call that C3. So what we're going to see is that a Sorites occurs when this and this are missing. Right? These are MIA, missing in action. So all we have, all we're given in a Sorites are a couple of premises and a conclusion, and sometimes they're all mixed up. And what our goal is going to be is to put these premises that we're given into the correct order, and then ultimately to supply the missing premises, or to solve these enthymeme problems. So what's the next goal going to be? It's going to be to put them into a standard form Sorites. A standard form Sorites. Now, what exactly does a standard form Sorites look like? Well, let's take a look at what your book says here. Right? A standard form Sorites is one in which each of the component propositions is in standard form. Each term occurs twice. The predicate of the conclusion is in the first premise, and each successive premise has a term in common with the preceding one. Now, there's actually two different types. There's the Gauquelinian and the Aristotelian forms of Sorites. This is the standard form, the non-Aristotelian or the Gauquelinian version of the standard form Sorites. But it's basically very, very simple, okay? Now, let's sort of go through here on how, let me give you an example here. Let's scroll back here to what one of these Sorites might look like, okay? Imagine, for instance, that someone gives you this argument. All bloodhounds are dogs. All dogs are mammals. No fish are mammals. Therefore, no fish are bloodhounds, right? Okay, so how are we supposed to put this into standard form? So these are let me give you the steps to put it into standard form. The first thing to do, in this case it's given to us, but is to identify the conclusion. First, what you have to do is you have to identify the conclusion. Now, the conclusion is easy because it's right here. Okay, therefore, no fish are bondsmen. So let's write it over here, because oftentimes it's easier just to put first letters here instead of using the actual terms. So no F or B. Okay, now the reason I want to identify the conclusion is actually very simple, because that way it tells me what the predicate term or the major term of the Sorites is, right? Which is, in this case, the letter B, or bloodhounds. Now, what that means is that bloodhounds must be in the first position. It must be the very first premise, and it is in this case, right? So let's go back here. So that means the second step is to reorder in standard form. Okay, so let's label this off. This would be no F or M. Right? All I'm doing is transcribing into the variable form just by replacing the terms, the subject and the predicate term here, with letters. This one would be all D, R, M, and this one is that all, whoops. This one says that all B, R, D. We'll actually take a look. Lo and behold, this one actually is in standard form, so we actually don't have to figure out what's next, right? Because take a look. The predicate term has to be in the very first position, right? Which it is. It has to be the predicate term of the conclusion has to be in the first premise. In other words, the major term has to be in the major premise, right? And then, of course, D becomes the middle term for M, right? And then M becomes the middle term to begin to talk about F. And then, of course, this is the conclusion, no F, R, M. Now, what we're going to do is we're going to reorder in standard form. 3, we're going to supply, I'll do a problem here in a sec that shows us, supply any missing premises or conclusions. And then finally, 4, once we've done that, we test for validity. This is the real simple procedure you're going to have to follow when you get these Sorites problems. And it's really not too difficult, right? In fact, your book, Patrick Hurley, the textbook here, talks about the idea that there's really 2 ways to test for validity. So let's sort of quickly do that. There's 2... here, we'll start it over here. Okay. There are essentially 2 tests for validity in order to determine the validity of our Sorites, right? So here are the 2 forms. We'll call this test A and test B. Test B is pretty simple. In fact, I think it may actually be better if I just write it out for you here. Type it out. I've noticed as I've been doing these videos that my handwriting's not the best. So let's go through here. The first test for validity is number 1 is to put the Sorites into standard form. Right. Once these are the steps to test for validity. Once you've put the Sorites into standard form, introduce the intermediate conclusions and premises, and then you test each component for validity. This is essentially the test that I just explained just a second ago. So what's the second test here? What's test B? So the first test is test B here is to use the 5 rules. Okay, so let's sort of show you what that looks like here. So in order to look for the 5 rules, here's what the 5 rules are, right? The first rule here is that each middle term must be distributed at least once. Okay, each middle term has to be distributed at least once. If a term is distributed in the conclusion, it must be distributed in the premise. Okay, number 3 is 2 negative premises are not allowed. And then rule 4 here is that a negative premise requires a negative conclusion, and a negative conclusion requires a negative premise. So I'll just put a negative conclusion requires a negative premise, and vice versa. And then finally, the last one is this: if a premise is universal, the conclusion can't be particular. And this basically sounds like our old rule, right? If all the premises are universal, the conclusion cannot be particular. Now, the caveat with that fifth rule, of course, as we learned in our previous lessons here, is that it is possible to have a conditionally valid argument that does have a universal premise. So this fifth one is really the test for Aristotle. You'll notice that pretty much all of these are the same, except this first rule, which is each middle term has to be distributed at least once. Okay? So these are the basic 2 tests for validity. Maybe I'll delete that since I moved around. Okay? These are the 2 tests for validity. So that tells you one thing, but let me actually do a problem for you. Let me do a couple problems so you can see how to do them, because right now all I've given you are the steps and I've sort of told you about it, but I haven't really demonstrated how to solve these problems, even though, ironically, you actually already know all of the information, right? Okay, so let's start with this problem. Let me snip this. Okay, now I'm going to use the first method here instead of using the second method here. Let's move this thing over. That's odd. Okay, well, let's just do it this way. Okay? So if we have this problem, the first thing we have to do is reorder it, right? So let's take a look at the conclusion. That's where you always have to start. This doesn't matter so much when you're looking at these sort of variable problems, but when you're actually trying to translate one from a real argument, you have to figure out what the conclusion is. The conclusion here is that some E are not D, okay? So that means D here has to be the very first premise. So let's take a look at here. Let's just reorder it around here. We're going to have the same conclusion here, so let's just leave that the same. So that's going to be some E. Where, you know what, I'll write it down here. Some E are not D. Okay? So that means that where's the D? This thing needs to go up top, right? So let's just write that in. All D are C. Now, if all the D are C's, the question is what comes next? Well, in this case, remember, if if C is the predicate term, if D is the predicate term, then that means that C is the middle term. So that means that this comes next here, because remember, basically it links together like a chain. So you get the D, the C, so then you're going to need this line, no B or C. No B or C. And then once you get this, no B or C, then the question is, what's the next linkage? Obviously, it has to be something that has a B in the title, which is that all A are B, right? And if all the A's are B's, then that means, let's see here, the next one is where do we move the next one? If all of the A's are B's, then that means we have to find the one that has the A in it, which is this one, some E. Some ERA. Okay, so what I want you to see here is that the way I figured out how to do this is I basically, once I figured out what this term was, then I just put that up top. I went, if there's a C, I'm going to have to go to a C. Now if there's a B, the next one has to be a B. But then that gives me the A, which means the next line has to have an A in it. So now that I've put this in standard form, what I now have to do is provide the intermediary conclusions. Okay? Now, let's start this over here. No, cancel. Okay. So let me move this. I'm not sure why my computer is not allowing me to extend this over the whole screen. Somehow there's something controlling it. Anyway, sorry about that. I'll just do it over. Well, dang it. Okay, let's redo this. I'm sorry. I'm going to have to start over again here. Okay, there we go. So, sorry about that. There's some sort of technical glitch there. So you can see here, here's the problem, and then here's how we reordered the problem, okay? Let me make that just a hair bigger for you guys, okay? So here's how I reorder the problem, okay? Now again, so hopefully that makes pretty good sense on how you're supposed to figure out how to put it into standard form, okay? Once it's in standard, just remember, when you put it into standard form, you basically want to sort of create a chain reaction in the series, okay? So now here's what we do. Remember, we're still missing premises and conclusions. So what you're going to do is you're going to take the first two premises here, and you're going to make this a conclusion. What would the conclusion be if these are your two premises? If all of the D or C, and here's where you can really use those 5 rules that we talked about. You can sort of reverse engineer those 5 rules to figure out what a conclusion is, right? You can see that it's universal, so the conclusion is universal. If it's a negative, you need a negative conclusion. So that means that the conclusion here is going to basically say that no B or D. No B or D is the conclusion of these two, right? Because remember, if this, let's see here, if this is the first premise, D, then D has to be the predicate of the conclusion, which means the subject here has to end up over here, the subject of the conclusion. So this is our conclusion. Now, what we should do is we should now test for validity, right? So what we're going to do is we're going to draw these as a Venn diagram to see if they demonstrate or they prove that this is the correct conclusion. So let's just draw them right here. All right. Okay, so let's label them down. This is going to be B. This is going to be D, and this finally, the middle term here is C. So remember, only diagram the premises. So all D or C, if all of the D's are C's, then that means I've got to fill this stuff in. Okay, all of the D's are C's. So check mark on that. What about no B or C? If none of the B's are C's, then that means I've got to fill this in right here. So that means that the B's are not C's. When it says no B or D, okay, if none of the B's or D's, here's where the D's are and here's where the B's are, this checks out. This first one is valid, okay? Now, and I apologize since I'm doing this on the computer, it's a little less neat than I'd like it to be. So that means that the first part of the argument checks out, but guess what? This line here, no B or D, is now going to operate. Let me see if I can select this. This conclusion here is now going to operate. Let's just move this over. There we go. This conclusion now is going to operate as the first premise of the next line. So I just basically scoot on over this premise here to say that all A or B, and you can notice immediately, right? In fact, we can just erase this line, right? So what I notice immediately is that all A or B here, right? The B here becomes the middle term. The D again is the, right? That's going to be the major term. This is the minor term. So I can basically function and figure out, well, what's my conclusion got to be? My conclusion has to be, right, that no D are A. That has to be the conclusion. Why? Remember, I'm just using these 5 rules, which means if I have a negative premise, I have to have a negative conclusion. I have 2 universals, it has to be universal as well. Right? The A here, oops, I wrote them backwards, didn't I? Let's see here, let's erase that. Hopefully you guys at home watching this video caught me make that little mistake there. Do you see why I made the mistake? Because remember, the subject, because I'm sorry, the D here should have been, it should say no A or D, because A is the subject of the minor premise, so it needs to be the minor term in the conclusion. It should say no A or D, okay? See, you can see here that this is why you have to be really sort of consistent and slow, and why practice will really help. Because even me, I've done these problems a million times. You can see here I am making small little errors myself. So let's scroll down here and let's do a sort of quick Venn diagram to see if this is valid. We're testing for validity as we go. Okay, so what are our terms, right? You can say that B is our middle term, and then A and D are our other terms. So let's just remember, let's just, when you do Venn diagrams, just diagram the premises. So the first premise is no B or A. If none of the B's or A's, then I need to fill in the football spot. Okay? And then the next one here says all of the A's, no B or D. I'm making lots of mistakes. I hope you guys are catching that. Right? No B or D, I need to do it here. I must be out of my element today. Okay. So then the next one here is that none of the B's or D's, and this says all of the A's are B's, which means I need to fill this spot in here. Remember that got filled in there too. All right, that's good enough. Now, what's the conclusion? The conclusion says that no A or D. Is that true? Well, here's all the A's, and look, none of them are D's. That checks out. That is also a valid argument. So we can write this first one is valid. The second one here is valid. We're going to have one more to test after this. Okay, so basically what you're going to do now is you're going to bring up this premise here, right? Oh, we're missing one in here. We're missing some E or A. So bring up this conclusion as your intermediary premise, and it's going to say no A or D. And then now I need to bring in this premise. Right? You can see I accidentally wrote it right here. Right? So it should say some E are A. Okay, so now we can ask ourselves, we make sure this looks right. We've got our D here. If this has to go here, and this E has to go here, right? So what should these words be? This should say that no, if you have a particular, then you need to have a particular conclusion. And if you have a negative, you have to have a negative conclusion. So this should say some E are not D. Some E are not D, right? And by the way, notice that is the conclusion. Some E are not D. Let's test it for validity, right? So that means what's the middle term? It's A in this case. And then what you get is E and D down here. So how would you do this one? Always diagram the universals first. So no A or D. None of the A's or D's, then it's going to look like this. And then the second one here says some E or A. If some of the E's are A's, then that means an X has to go, it's kind of hard to tell, but it has to go right there. Okay? Now, the question is, can you read the conclusion? Some E are not D. Well, there are some E's and those are not D's. This also works out as valid. Okay? So this is, you can see here that this argument here, even though it was missing two different premises, is actually a valid argument. Once it's put into standard form and analyzed. In this case, we use Venn diagrams to test our analysis. Now, I did mention, though, there is another way to test for validity. And you can see here, he gives, I think, probably a better, mine was sort of confusing to look at, but I wanted you to see me at least doing the problem. But you can see here, he does the exact same thing. And this is exactly how I want you to do it, too. I want you to draw it out using these sorts of arrows and lateral diagrams. Okay, here are the rules though, right? Each middle term, right, must be distributed at least once. If a term is distributed in the conclusion, then it must be distributed in the premise. Two negative premises are not allowed, right? A negative premise requires a negative conclusion, and a negative conclusion requires a negative premise. And rule 5 is if all the premises are universal, the conclusion should not be particular. It needs to be universal. Okay, so basically the rules are very similar. The rules are actually more helpful because the rules allow you to really, once you put it into standard form, to really quickly assess whether or not it's going to be valid. And you can just use those rules. And so literally, instead of doing the diagrams here, we could have just tested for the rules, and if it passed the rules, it passed. And of course, since the Venn diagrams worked out, the rules also work out simultaneously. So that's how you do Venn diagrams. I'm sorry, not Venn diagrams, do a Sorites. So let's do another Sorites problem. Let's do a problem from the homework, actually. Just so you get a sense. Let me do this first problem homework. Let me scroll down. And these really aren't that difficult. At least I don't think they are. I think where they get a little tricky is just make sure you figure out that conclusion is and set up that first line, that first major term. Make sure to set that up. If you can set that up, you're in good shape to solve these. They're not that difficult. It may just take a little time of practice. Okay, so let's see here. We'll do this one. Here, we're still stuck with my thing. It's somehow broken. Let me see how big I can make this. Let me just do this. Okay, so here we are. We're taking a look at our next problem here. This is the first problem from the homework. And yeah, I think once you start doing these, you'll see that it's really not too difficult to do. Okay, so let's go ahead and start. Okay, so remember the first thing we have to do to solve this problem is we have to put it in the correct order. So, and the way you look at it, look at the predicate of the conclusion here, the A. The A is going to have to go up here, right? So we know that that's going to be after first line. So let's rewrite it down here. So it's going to be basically all A or B. And then once we get that premise, now we have to find, right, since the A is in there, right, what we have to do is find the next one that has a B. That's obviously this one, so this one stays where it goes. So we get no B, RC. And then finally here, well here actually, why don't we just stop and figure out, because we know that we're missing a premise, missing the intermediary premise here. So let's real quick figure out what's missing. I'll write it in red so we know it's missing. Well, what's the conclusion? If you have a negative and you have a universal, this has to be a universal negative. So this is going to be no C, R, A. And remember, the reason I knew how to do that was because the A here, since it's in the major premise, has to be in the major term of the conclusion. So this is going to be the intermediary conclusion. Once we get the intermediary conclusion, then we can sort of ask, well, what comes next? Right? Well, we've already dealt with that. We dealt with that. It leaves just this one right here. And you can see C is in there, so it gives us, think of it like Legos. You have to link these terms together in order to properly analyze it. So it'll be sum D R C. Now we know what the conclusion is here because the conclusion is what comes next, and that's this conclusion: sum D are not A. Okay. Now once we've written it into standard form, right, and this whole thing is, I'll just put SF here for standard form. Once we put it in standard form, now we have to assess each individual argument for validity. Now remember, we've got really two different arguments that are sort of smuggled together, right? These two arguments. So that means we're going to need two Venn diagrams. Of course, I can just take those 5 rules that we just talked about, and I could use those 5 rules to analyze it. But I like drawing, so I'm going to draw a diagram here. So let's just do our little Venn diagram. And they can be sort of messy. Hopefully they're not quite as messy as mine. All right, I'll move it over just a little bit. Okay, there we go. Okay, now remember, diagram just these. So the first one here is all the A's or B's. Oh, forgot to label. So don't forget to do that. It's going to be C and A. So all of the A or B. If all of the A's or B's, then that means that this stuff gets filled in, these 2 circles here. I'll be quick and sort of loose about it. And so I've diagrammed that. And then I have to diagram this one, no B or C. If none of the B's or C's, then that means this thing has to get filled in the middle. Okay, so now the question is, I've actually diagrammed the argument. So the question is, can I read off the conclusion from the diagram? The conclusion is no C or A. No, and look, all the C's are separate from the A's. The A's are right here, and all the C's are here. So it's true, no C or A checks out, it's valid. Okay, so now let's diagram the next one. And if both of these work out, then, you know, awesome, we have a good valid syllogism. If not, then we have a load of crap we can not worry about. I shouldn't say that on video, so sorry, class. let's see here. C, okay? So my middle term is C here. Now, let's diagram this. If no C or A, if none of the C's or A's, then that means I have to fill in the little football spot between the C's and A's. So all of the C's are separate from all of the A's. And then I just have to have a particular premise here, some D or C. Remember, when you have a particular, you just put an X in. So if some of the D's are C's, then a little X goes right here in the middle. And since it's kind of small, it's hard to see, but that's where you put it. So then the question is, can I read off the conclusion from the premise? I'm sorry, from the diagram. Some D are not A. So here's a D, so there are some D's, and look, that D is not an A. So that means this is also a valid argument. Two valid arguments means you've got a valid Sorites. Right? And so we can all be happy. But that's effectively how you do these diagrams. Now, to show you briefly here in your homework, you're going to see that what you have to do is you have to rewrite them first into standard form, reduce the number of terms when necessary. And actually, you guys aren't going to have to do that because we didn't cover that, and you guys are using the Applia, but that is something you have to do. And if you are to reduce terms, take a look at, I think it's section 5.5, which basically tells you to use inversion, contraposition, and conversion to get rid of terms and this sort of thing. But that's not a big focus. It's not going to be on the test, actually. And then you can see here, then they're going to give you Sorites, but that are ordinary language. And what you need to do with these is you need to put them into the formal symbols, like we did before, where whatever produces oxygen supports human life. That's going to be all things that produce oxygen support human life. So something like all A are S, things that support life or something. You're going to put it into the formal argument, and then you're going to add in, supply the missing premises, and then test for validity, just like we did before. It's really quite simple. Just be slow and deliberate, and I think you'll find that these are actually sort of fun, and that's the trick. If you can actually enjoy doing these problems, the truth is you'll actually do a lot better for the problems. It's when you hate to do it that you usually do poorly. So hopefully think of them as puzzles, and I think you'll enjoy it. So that's Sorites. You'll see that after this we're going to start talking about propositional logic, and we're going to move away from this. So, but this is our section on Sorites. Thanks for watching. I'll see you guys online. Okay, bye.